So welcome to your very first app with Node.js. In this screencast, we'll write a very simple server application that displays Hello Node.js in the browser. But first, let us understand what a server actually does, and this is pretty much going to be a platform agnostic explanation. A server is software that listens to requests that a user makes and responds appropriately. This is sort of like a server at a restaurant. You order a pasta, and the server takes your order into the kitchen where it gets processed, and once it's prepared, the server gets it to your table. So for you, the diner, the server is the source and the go-to person for placing orders and requests and getting food and the bill at the end. Now, applying the same analogy to a web server, when you open your browser and type www.somewebsite.com, and for our example, let's say it's google.com, your request, after traveling over the web, reaches a software running on a computer somewhere known as a server. The server then analyzes your request and fetches the data from its hard drive or perhaps a database or someplace else, and it sends it back to you. But before sending the data back to your browser, as a response, the server sends a header. The easiest way to understand a header is an instruction to your web browser to expect data of a particular kind. So let's say you requested a JPEG image from the server will first send a header which looks like this. The left part of this statement says content type, which signals the browser to take a note of what's coming next. The right part of the statement, after the colon, is where the server actually describes the kind of data that it is sending. So for a JPEG image, this would be image/JPEG. These are also called MIMEs or multi-purpose internet mail extensions, and it was a specification originally designed to describe various kinds of content types for email applications. This was, however, also used for data transfer protocols like HTTP, as we can see here, in the case of a web server. So, after the server sends the header, it then follows it up with the actual content before closing the connection. Another thing that goes along is an HTTP status code, which is a 3-digit number that describes the state of the response. So for instance, if everything's okay and the content is being sent by the server, the status code would be the number 200. On the other hand, if the user has requested some web page or content that does not exist on the server, then the server returns the status code 404, which means content not found. Similarly, you've got 500, which is sent if the server encounters an error processing the request, and so on. If the user creates another request, then the entire process repeats again. Now, let's try and implement this using Node.js. So first, in your text editor of choice, and I prefer using Sublime Text, create a new file and we'll save this as hellonode.js. Remember, Node.js is JavaScript on the server, so all files would have the JS file extension. Next, within single or double quotes, type use strict and end it with a semicolon. The use strict expression enables a restricted mode of JavaScript that intentionally prevents bad coding practices and eliminates the use of mistakes that result in inefficient code. So ideally, put this expression on the first line of every JavaScript file that you write, and you're off to a better start already. Here in Node, and at the time of this recording, the use strict expression does something more. It enables the use of ES6 features that Node.js supports out of the box. In the future, you should not be explicitly needing the use strict expression. However, as a better coding practice, always prefer using it. On the next line, I'll create a constant identifier called HTTP, and we are using a constant because we do not want this identifier to be used anywhere else again. And I'm going to set it to require Node's HTTP module. Now, one of the strong points about Node.js originally was its use of the CommonJS module format and the ability to bring in functions or methods written in external files. While a regularly used and standard feature as far as other languages like Java or Python go, JavaScript never really had the native luxury of segregating functionality into manageable components spread across files. Therefore, specifications such as CommonJS and AMD filled the gap by adding support for modules and enabled developers to have real modules which could be easily imported into other files and scripts. Since Node.js was born in the pre-ES6 era, it uses the CommonJS specification as standard for bringing modules in from external files. ES6, on the other hand, has brought modules as a native functionality within JavaScript. But at this point in time, I would not want to use it for the reason that Node is still working on a stable implementation of the ES6 modules, and though you can in fact use modules in Node today, I would advise waiting till it becomes officially announced as a ready-to-use and stable feature. Hence, we'll stick to the require statement for bringing modules in for now. Now, a module is essentially a JavaScript function for most parts, or it could be an object containing a number of useful methods and properties. So when you access a module using the require statement as we've done here, that function or object is then available directly inside our Node.js script and is accessible using the identifier or variable that we use here. So here, the require statement brings in one of the built-in modules that come as a part of Node.js known as HTTP. This particular module provides us with a number of methods that allow us to create server instances and do other HTTP related tasks. So once this is done, I will access this module using the identifier HTTP that we just created, and then I'll follow it up with a dot and we'll call a method called createServer. The createServer method is part of the HTTP module, and as the name implies, it creates an instance of a server that listens to incoming requests that a user makes and allows us to respond to those requests as needed. Now, like most methods in Node.js, the createServer is asynchronous, which means it doesn't block the JavaScript event loop while it is waiting to respond. So how do we use this method? Well, start by defining an anonymous function inside the method call like so. This is known as a callback and is executed once the createServer method is ready to execute and respond. This is where all the logic for this method will go. Now, a server listens to requests and responds accordingly. So we'll provide our callback with two arguments, a request or REQ in short, through which this method brings in the user's request, and a response or RES in short, which allows us to dispatch an appropriate response to the user so he can receive it in his browser, for instance. You can see that I'm using an arrow function here, but you can use a standard JavaScript anonymous function or refer to a named function as well. Now this server of ours will just send back an h1 tag with the text hello Node.js to the user. So there isn't much technicality that we will get into. Therefore, the next thing that we'll do is access the response object by using the res variable and access a built-in method called writeHead. Now remember when I said that the server sends an HTTP status code and a header before sending in the actual data? So this is what the writeHead method will accomplish. So first, I'll send an HTTP status code of 200, which means OK. Then we'll put a comma and we'll send an object which will contain the header. So type content-type in single quotes or double quotes, and after the colon in the quotes we'll type text/HTML because we'll send one HTML string to the user. Next, we'll access another response method called end, and practically this sends the actual data and closes the response. Inside this method, we'll type out our HTML string, which is an h1 tag with the message hello Node.js. So this creates your instance of a server. Pretty cool, right? But this server won't do a thing unless it listens to a specific port on your computer. Data flows in and out through gateways on a computer known as ports. Typically, web servers work on port 80. However, we will not use port 80 here, but instead, we'll make our server listen and respond on port 3000. For this purpose, I will chain in a listen method which accepts two arguments. The first one is the port number, so I'll type 3000 here. And the next one is an optional callback where I'll just use console.log to print out a message which says server running on port 3000. And that's it. Now open up your terminal and navigate into your folder which contains the hello-node.js file. To run the server, we'll type node followed by a space and followed by the name of the file, which in this case is hello node. You may or may not type in the .js extension. Press enter and you can see the message server running on port 3000, which we console logged out from within the callback in our listen method. At this stage, your server is waiting for a request. So let's open up our browser and type localhost:3000. Localhost refers to your own machine's address and our server is running on port 3000 as you would recall from the listen method. And you'll get a big bold h1 tag which says hello node.js. So this is how you can write a very simple server instance. But what if your server is required to respond to multiple route requests such as these? Let's go a step further and implement basic routing in our server in the next screencast.